Ever since we were kids, we've been taught in school that Earth and all the other planets revolve around the Sun, and that the Sun, in turn, orbits around the center of the Milky Way galaxy. But is it really as straightforward as it sounds? Well, to be fair, it might be just a little trickier than subscribing to this channel. Although, I'm sure you can all handle that, right? Because you're smart like that. Hey there, everyone! So, how exactly does the Sun move around the center of our galaxy? What kind of path is it following through space? And where in the Milky Way was the Sun actually born? Why is it so hard to pinpoint its exact birthplace? What makes the location of our solar system so special and lucky in the grand scheme of the galaxy? You're watching our channel, and we're so glad to have you here. Today, we're diving into all of that and plenty more you might not expect. So let's get started. The Cosmic Dance. Just a quick heads up before we dive in. If you've got a vivid and active imagination and your inner ear balance isn't the strongest, it might be a good idea to grab some motion sickness medicine before watching this video. That's because if you try to fully picture everything we're about to explain, it might just make your head spin, literally. First things first, forget everything you learned in school for a moment. That simple image of planets, asteroids, and comets quietly circling the Sun is only true in the roughest approximation. The reality is far more complex. When two celestial bodies are bound together by gravity, they don't just orbit one another randomly, but they both spin around a shared balance point where their gravitational pull evens out. That point is known as the center of mass, or more simply, the barycenter. In the case of the Earth and the Moon, that barycenter sits inside the Earth, but it's not right at the core, it's actually closer to the surface. So if you were an observer floating outside this system, it would look like the Moon is circling the Earth, while the Earth itself is gently wobbling and sort of tumbling in its place as it spins. Interestingly, this subtle wobble is the reason why Earth experiences far more intense tectonic activity than Venus or Mars. In fact, you might not realize it, but Earth is actually one of the most volcanically active places in our entire solar system. The only object that tops it is Io, which gets violently stirred up by Jupiter's immense gravitational force. Where the barycenter ends up depends heavily on the mass ratio between the two objects, and the Sun-to-Earth ratio is way bigger than the one between the Earth and the Moon. Just to put it in perspective, the Sun holds a staggering 99% of the total mass of the entire solar system. And even though every planet is tiny compared to the Sun, both in size and mass, their gravity still tugs on it enough to make the Sun wobble slightly. On top of that, the planets don't just pull on the Sun, they also influence each other, constantly interacting in subtle ways. Right now, the orbits of the planets are incredibly stable, and none of them are flying off course. Still, the whole solar system experiences a bit of a jitter, depending on where all the planets and other objects happen to be at any given time. This grand cosmic dance has been playing out continuously, without missing a beat, for billions of years. And sure, if you try to picture all those little wobbles happening rapidly, it might make you feel a little dizzy. But those movements don't throw off the stability of the system as a whole. It's kind of like a pendulum, because even though it's always in motion, it still maintains a steady rhythm. However, once we start zooming out to much larger scales, everything changes dramatically. Galactic Chaos. All the stars in the Milky Way, including our Sun, are orbiting the galactic center, where a supermassive black hole sits with more than 4 million times the mass of our Sun. But unlike planets, these stars don't follow neat, stable orbits. Why is that? The answer is actually pretty simple. Gravity is a property that applies to all matter, not just the center of celestial bodies. In other words, it's not the center of an object that creates gravity. It's every bit of matter that makes up that object pulling from all directions. This is also why the very center of Earth is a point of zero gravity. If somehow you ended up at the exact center of Earth, you'd be pulled equally from all sides by the planet's mass, perfectly balancing out the forces. But let's get back on track. The real point is, gravity comes from clusters of matter themselves. Like we mentioned earlier, the Sun makes up 99% of all the matter in the solar system. That may sound huge, and yes, compared to Earth or Jupiter, it absolutely is. But in the grand scale of the solar system, even the Sun is just a small piece. The space between the Sun and Mercury alone is so vast, you could fit 40 more stars the size of the Sun in there. And it only gets exponentially bigger the farther you go out. So, while the Sun is the central mass and gravitational anchor of the solar system, it's also a relatively small and compact body in that vastness. When it comes to the galaxy, things get way more complicated. That supermassive black hole does have incredible mass, but in the scale of the Milky Way, it barely registers, as it takes up less than 100,000th of all matter in the galaxy. The entire galactic disk, along with the invisible dark matter halo that surrounds it, also contributes gravitational pull. Without that halo, even the black hole couldn't keep the Milky Way from tearing itself apart. This is exactly why the Sun's orbit around the galactic center is anything but stable. The Sun is constantly being pulled toward clumps of matter in the galactic disk. And the greatest concentration of that matter lies in the galactic core. But it's not just one lonely black hole sitting there, since it's packed tight with thousands of stars all jostling for space. While mass is generally spread out across the galaxy, sometimes it clusters more heavily in one direction, and when that happens, it actually shifts the path of the Sun's orbit. Right now, the Sun and all the planets are barreling along on a chaotic, ever-shifting path at a staggering speed of 514,000 miles per hour. Because the Sun's orbit is so unstable, we can't say exactly how long it takes to complete one full lap around the galaxy, a so-called galactic year. On average, though, scientists estimate that one galactic year takes about 230 million Earth years. Just imagine that one galactic year ago, Earth had only just entered the Triassic period, and the very first dinosaurs were starting to appear. So hold on tight, because what you're about to learn is going to blow your mind. Right now, sitting at your computer, you're hurtling sideways through the galaxy, almost lying on your side. How is that even possible? The answer is once again surprisingly simple. The orbits of all the planets in our solar system lie mostly in the same flat plane as the Sun's equator. That flat surface is called the ecliptic plane. In illustrations and science diagrams, it's usually drawn as perfectly horizontal to make things easier to understand. But in reality, the Sun itself is tilted on its axis, which means the ecliptic plane is tilted too by about 60 degrees compared to the plane of the galaxy. So rather than sitting upright, you're actually hanging at a sharp diagonal angle right now. Thankfully, our sense of balance isn't based on cosmic orientation, but is based on gravity, just like with most living creatures. If it weren't, we'd be feeling pretty nauseous by now. Ever wonder why the Milky Way looks like it cuts across the night sky at an angle? Now you know. And from now on, you'll never look at the night sky the same way again. Don't say we didn't warn you. We did give you a heads up at the beginning, remember? Like all the other planets, Earth orbits the Sun in the same direction that the Sun spins. As the Sun moves through space, Earth sometimes ends up ahead of it and sometimes trails behind, constantly shifting positions. But don't worry, this doesn't have any effect on life here on Earth. That's because we're tucked in close to the Sun, deep inside a protective bubble called the heliosphere. This bubble surrounds the solar system and shields us from dangerous cosmic radiation. If we were way out in the Oort cloud instead, we'd definitely be feeling even the slightest fluctuations in that radiation. Even though the Sun's orbit is unstable, it still seems to stay within a certain region of the galaxy. For a long time, we thought the solar system sat on the very edge of the Milky Way's disk, but it turns out we're more like near the edge of the middle. And that's actually a pretty great place to be. It keeps us safe from the violent chaos of the galactic core and from the gravitational pull of other galaxies too. Plus, the Sun happens to be traveling along what's known as the co-rotation circle, where stars move at the same speed as the spiral arms of the galaxy. Those famous spiral arms aren't fixed in place, they're more like waves, sometimes sweeping up stars into them, sometimes letting them drift away. The waves move at a steady pace, but the stars themselves all orbit at different speeds depending on how far they are from the center. The farther out a star is from the galactic core, the slower it spins. Outside the co-rotation zone, the spiral waves chase the stars and occasionally catch up, pulling them into the arms. And that creates a serious problem. When stars get swept into the arms, they can get dangerously close to one another and destabilize their planetary systems. And there's no guarantee that one of those stars won't go supernova. So yeah, we're insanely lucky. Because we're moving just behind one of the spiral arms at exactly the right speed, we're not catching up to the wave and it's not catching us either. That means even though the space around us is spinning in wild, chaotic motion, the solar system itself remains surprisingly stable. And that stability has allowed it to survive for 4.5 billion years, which was long enough for life to evolve and thrive on at least one of its planets. So, all things considered, our little neighborhood in the galaxy is a pretty fortunate one. Sure, we're not smack in the center, and we're kind of sideways and maybe even a little upside down, but still, we're in a good spot. If you enjoyed this video, go ahead and hit that like button and share it on social media. Thanks so much for watching. We'll see you again soon. Take care.